Welcome students. In this video, I am going to discuss ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. Here I have taken two fixed points, say F1 and F2. Now point P1, P2 and P3. All these points will lie on the ellipse if P1 F1 plus P1 F2 means the sum of distances of the point P1 from these two foci is equal to this P2 F1 plus P2 F2 is equal to P3 F1 plus P3 F2. All these are equal and is equal to some constant. So we can say all those points, the sum of whose distances from these two fixed points F1 and F2 in the plane is constant will lie on this ellipse. Now these two fixed points are called the foci of ellipse. This word is the plural of your focus. In case of parabola, we are having only one focus, but in ellipse, we are having two fixed points. So these two are focus, or we can say these two are the foci of the ellipse. Now, just look at these diagram. This is your ellipse. This is F1 and F2 are your fixed point, mean these two are your focus. Now, the important information regarding the ellipse is the midpoint of line segment joining these two foci is called the center. The midpoint of line segment joining these two foci is called the center. In our syllabus, we are going to take the center at origin. For standard cases, our center will be always at 0, 0. So this O is called the center of ellipse. The next thing is the line segment through these two focus of the ellipse is called the major axis, or we can say the focus will always lies on the major axis. So this line segment through these two focus or through these two foci is called the major axis of ellipse. Next, the line through this center, we have taken the center as O. The line through this center and which is perpendicular to major axis is called the minor axis. Now this is a line, this line segment. If I write this as CD, that means in this diagram your AB is the major axis and this CD, the line segment through the center and perpendicular to your major axis is called the minor axis of ellipse. Next, the end point, the point A and B here are the end point of your major axis. This is your A point. End point of major axis are called the vertices of ellipse. So we have taken the fixed point F1 and F2 as the foci of ellipse. Then the midpoint of line segment joining these two focus is called the center. Here your center is at 0, 0. The next thing is the line segment through these two focus is called the major axis. Here AB is the major axis. Next, the line through center and perpendicular to this major axis CD is called the minor axis of ellipse. The next, the end point of this major axis, here A and B are the end point. These are called the vertices. A is also vertex and B vertex. So we have A and B as the vertices of this ellipse. Now again look at this diagram. Here F1 and F2 are both focus. We denote the length of major axis. These are standard notations. We denote the length of major axis by 2a. That means if this is A and this end point is B. A and B here are vertices. The length of major axis AB is 2a. This is your standard notation. Then the length of minor axis, I have denoted this complete length AB as 2a because the center we have taken at the origin. So this is half and this is also half. A and A. This A is known as the semi-major axis of ellipse. Then, if this is capital C point and this is D. So, this CD, this is your CD, the length of minor axis. We denote the length of minor axis by 2B. And the distance between these two focus is 2C. This complete distance F1 and F2, distance F1, F2 is 2C. Now we know that this ellipse is symmetrical along x-axis as well as y-axis, right? So this half is C, this is also C, and the distance F1 and F2 is 2C. This is your minor axis 2B, and this is B, and this is also B. Here the major axis 2A and half is semi-major axis. So I have written the length of semi-major axis is A and semi-minor axis is B. Next is the relationship between the semi-major axis, that is here A, semi-minor axis B, and the distance of focus from the center of ellipse. Here this distance of focus from this center is C, right? And the distance of focus from center of ellipse, right? So that means we are going to find the relationship between small a, small b and small c. So this I have taken again one more diagram for ellipse. F1 and F2 are your fixed point, right? Then take a point P at one end of major axis. The major axis is that axis on which your focus lies, or the line segment through the focus is the major axis, right? And take a point Q at the end of minor axis. Now, by the definition of ellipse, we know that an ellipse is the set of all points in the plane, the sum of whose distances from two fixed points, and F1 and F2 is constant. So, by definition, PF1 plus PF2 must be same as that of QF1 plus QF2. Now, this portion OP is your semi-major axis. The complete here is, if this is P dash and this is Q dash, this P dash P is major axis and half OP is the semi-major axis. So this distance must be A. Now this Q dash is minor axis. So its length is 2B. So if you write the distance OQ, this must be equal to B. And the distance of any of these two foci from the center is C. So this distance is C. Now, first PF1 plus PF2, this must be same as that of QF1 plus QF2. PF1. Look at the diagram. This portion is A. Here this is A and this is C. So this PF1 must be A plus C. Now PF2. You have to find this distance. This OP is A and this is C. So that means this must be A minus C. Now come to QF1. Join these two, QF1 and QF2. Look, this is a right angle triangle. With this side B, this is C. And this QF1 and QF2 are the hypotenuse. So by using Pythagoras, these two must be equal to root b square plus c square. Same way QF2 is also root b square plus c square. So I have written this. Now here this c will be cancelled. So a plus a must be 2a is equal to twice of root b square plus c square. Here this 2 is cancelled. Now do squaring on both sides. So you'll get a square is equal to b square plus c square. So the relationship between a, b and c is a square is always equal to b square plus c square. The next term is the eccentricity. The eccentricity is denoted by E. Now the eccentricity of an ellipse is the ratio of the distances from center of the ellipse to one of the foci and to the one of the vertices of the ellipse. That means this is C by A. If you look at the diagram, this was your diagram. So eccentricity is the ratio of distance from the center. This O was your center. Distance from center to any of the distance from center to any of the foci. So distance of center from any of the foci is C. To the distance of this center from any of the vertices, that is A. So this is C by A. If you look here, clearly this C is less than this A. So C is less than A. That means numerator is less than denominator. So eccentricity of ellipse is always less than 1. Now I am going to discuss some standard equations of ellipse. The equation of ellipse is simplest if the center of ellipse is at the origin and the foci are on x-axis or y-axis. Here I am going to discuss two standard cases of ellipse. This is your first case. Now, this case, when the denominator of x square by a square, here in the first case, denominator of x square by a square is greater than the denominator of, that means if the denominator of this x square by a square, this is the denominator, is greater than the denominator of this, then your major axis will be along x-axis. So this is your first case. An equation is x square by a square plus y square by b square equal to 1. The distance between these two foci is 2c. So this is c. So that means this coordinate, the major axis is along x-axis. So this is c0. Here to the left of origin, this is negative minus c0. Now the end point of major axis, A and B are the vertex. This is A. So this is A0 and this is minus A0. So foci are plus minus C0. The vertices are plus minus A0. Now the length of major axis is 2A. Here the length of minor axis, is 2B. Then the second case, when the denominator of this factor is greater than denominator of this factor, then your major axis will be along y-axis. I am again repeating, the denominator of y square by a square is greater than the denominator of x square by b square, then major axis will be along y-axis. So are these two focus will lie on y-axis. We know that the distance between two focus is always 2c. So this is c, this is also c. So the coordinate here are 0, c, and this is 0, minus c. The vertex, major axis, vertices are the end point of major axis. The length of major axis here again 2a, length of minor axis again this length is going to be 2b. This is coordinate 0a and this is 0, minus a. So vertices are 0, plus, minus a. Next is the lattice rectum. Now lattice rectum definition is exactly same as that was in parabola. Lattice rectum of an ellipse is a line segment perpendicular to this major axis. This is your major axis through any of the foci and whose end point lie on the ellipse. I am again repeating, lattice rectum of an ellipse is a line segment which is perpendicular to your major axis. This is your major axis. So these two are AB and CD. Here are lattice rectum, right? Is a line segment perpendicular to this major axis through any of these two focus. Maybe it may be through F1 or through F2, right? And whose end point must also lies on the ellipse. So AB or CD both are here lattice rectum. In both the cases, the length of lattice rectum is 2b square by a because we have denoted the larger denominator in both the cases by a. So this formula will remain same in both cases. This is 2b square by